In this Maths Olympiad question, we need to find the integer solutions to the equations ab plus c equals 2020 and a plus bc equals 2021. So here's our equations. ab plus c equals 2020, which I've labelled equation 1, and a plus bc equals 2021, which I've labelled as equation 2. Now if we do equation 2 minus equation 1, the left-hand sides, we're going to get a plus bc minus the ab plus c, and that's going to equal the right-hand side subtracted, so 2021 minus 2020. Bringing out the brackets, that means we get a plus bc minus ab minus c, and that's going to be equal to 1. Looking in the middle of our expression on the left there, we've got two multiples of b. So let's factorise that b out, and we get a plus b times c minus a minus c equals 1. We can see that we've got a and c outside our bracket on the left, and we've got a and c inside. So let's bring the a and the c outside together to make an a minus c. We've still got the plus b times c minus a there, and it's all equal to 1. And the brackets a minus c and c minus a are almost the same, but one of them is a negative multiple of the other one. So we can change this into a minus c minus b times a minus c equals 1. So changing the sign of the b means we can change both signs inside the brackets to get a minus c. And we've now got two lots of a minus c there. So factorising those out, we get 1 minus b times a minus c is equal to 1. Now remembering that our solutions are integer solutions, this means that 1 minus b and a minus c must also be integers. Well, there are only two pairs of integers that will multiply together to make 1. It must be 1 times 1 or negative 1 times negative 1. So we've got two cases. Let's do these one by one. First case, where both of them are equal to 1. Well, if 1 minus b is equal to 1, that means b must be equal to 0. We can now put this 0 into our original two equations. Equation 1, if we put b as 0 in, the ab disappears. We're just left with c is equal to 2020. Likewise for equation 2, the bc would disappear, and so we'd be left with a equals 2021. So there's one set of solutions. Let's try our other case now, the minus 1s. So if 1 minus b is equal to minus 1, b must be equal to 2. We're going to substitute that into our first equation now, so we would end up with 2a plus c equals 2020. And we also know in this case that a minus c is equal to minus 1. We've got two simultaneous equations here. If we add them together, the c's will cancel out. So we end up with 3a equals 2019, dividing through by 3 gives us that a is equal to 673. We can now put this back into our a minus c equals minus 1. So 673 minus c equals minus 1, which means c must equal 674. So there we go. We've got two sets of solutions. Either a equals 2021, b equals 0, and c equals 2020, or a equals 673, b equals 2, and c equals 674. If you've enjoyed this video, don't forget to subscribe to the Doing Maths channel or check out some more of my videos by clicking on the links here.